Hi guys, today we are working on solving systems by substitution, and I've gotten some notes for us here, and we're going to go step by step. I have two equations. One has two variables and the other has one. We're going to focus on the equation that has one variable first, so we're going to choose that. We have negative 2x plus 6y equals 18 and 3y equals 15. So I'm going to write down 3y equals 15 right here, because it only has one variable in there. For step 2, we're going to solve for the variable using inverse operations if needed. So I'm going to write over here, I want my variable to be isolated. I want it to be fully by itself. So we have 3y equals 15. 3y tells me that 3 is going to be multiplied by the y. So how do I undo multiplication? We're going to undo it with division. So we're going to do dividing by 3 on both sides. So I'm going to cross out 3 over 3. And I'm going to go over here to the right, we're going to say 3 over 3 equals 1. So whenever I cross something out like that, I am saying that is 1. Anything times 1 is itself. So 1 times y is y. So we can just write down y equals 15 divided by 3. That is 5. All right, now we're going to plug what the variable equals into the other equation. My other equation is negative 2x plus 6. Instead of my y, I'm going to substitute in 5. We're going to plug in the 5 for right there. And over to your right, I want you to put in parentheses. Okay, that's important because eventually we will have equations that have more things that we are substituting in, and you have to make sure you distribute whatever's on the outside of those parentheses to everything in there. So it's just a good practice to go ahead and have those parentheses there. Then we're going to put equals, and then it's 18. Now we're going to solve for the remaining variable. We have to remember when we're solving for anything, we have to remember our order of operations. An easy way to remember our order of operations is to use PEMDAS, which stands for parentheses, exponents, multiplication, division, addition, and subtraction. So our first thing in this equation is to do 6 times 5 because multiplication. We could say this is just multiplication, or we could say this is our parentheses. Either way, that comes first. So we're going to do 6 times 5 is 30. Then we're going to drop down everything else. So negative 2x plus 30 equals 18. Now we're going to solve for our x by isolating it because we've done everything that we can really do on the left side. So we're going to do the inverse operation to adding 30. So we're going to subtract 30. Okay, 30 minus 30, that is 0, which actually, I'm just going to write it right here. I don't have to cross it out. I can just say 0 and drop down everything else that we didn't use. We didn't use that negative 2x, so we're just going to drop that down. 18 minus 30, so if I say 30 minus 18, I'm going to get 12. Then we're going to take the sign with the bigger one. So we're going to have negative 12 here. I can completely ignore that 0 in negative 2x plus 0. So now we have to determine what's happening between that negative 2 and the x. And I can see that that is multiplication. So what we're going to do is we are going to divide by negative 2 on both sides. So x, I'm going to leave out that 0. I don't need it. X equals negative 12 divided by negative 2. I know a negative divided by a negative is a positive, so I'm going to march straight through those lines. We don't have a negative anymore. 12 divided by 2 is 6. And if you need a reminder of why I crossed out that negative 2 over there, so negative 2 over negative 2, negative over negative is a positive. 2 over 2 is 1. So I can just cross that out. Now we're going to write our final answer as an ordered pair. Our ordered pair here is going to be 6, 5. X always comes first. X comes first in the alphabet, so it will always be X, Y. And the very last step that we want you to do is to check your solution. We can verify if we made a mistake before we even turn in our work by plugging it in. In this case, you want to plug it in to the top equation because it has both variables in it. If you plug in just the y up here, so if we say 3 times 5 equals 15. 3 times 5 is 15, 15 equals 15, but we didn't check both variables. So it's important you check both of them. So let's do that. Let's plug that into the top equation. So we're going to do negative 2 times 6 plus 6 times 5 equals 18. Multiply negative 2 times 6, and we're going to get negative 12. Multiply 6 by 5, we're going to get 30. And then we're going to drop down our 18. Negative 12 plus 30 is 18. 18 equals 18. If that is correct, then we did our job right. Let's move this off of that line. Okay. All right, so after I have given a thorough example, such as this one, typically I would probably do more than one example, but for the sake of time, I just did one and made sure I showed a more difficult one where we had to solve for the variable first. So then I would give my students 2 practice problems to do, and I would probably have them walk through it with me. So I would guide them through these 2 practice problems before letting them loose to go on to homework problems or additional practice problems. So if I had a student who was struggling to get through practice problems with me, or we've already done those practice problems and somebody else helped, then I would want to make sure that their understanding of one-step equations is thorough enough, and probably go over some multiplication and division. I could also go through and make it a real-life scenario. What if they're going to the grocery store and they need to buy, they have X amount of dollars in their pocket and they need to buy all of these groceries? How much can they buy? How much money can they spend? We could make it into a real-world scenario. If I were to have some high flyers in my class that need to be challenged a little bit more, I could add in some challenging questions onto their homework problems and possibly push them onto the next objective that we'd be looking at. So in this case where we're doing substitution, I could give them one where they need to substitute an expression into an equation.